Hey everyone, we are RedCarbon, the 70th team. We have 9 people working on our rocket and satellite missions. We are high schoolers from Deneb. In this video, we are gonna talk about Signum 22, which is our PocketQube style satellite, competing in PocketQube or CanSat style satellite challenge. Our aim is to collect data from the sky during the satellite's journey and to be able to analyze this data. We spread out our missions that needs to be done over time, and here you can see our timeline. Currently, we are on the second step. You can see our budget list here.
Signum is a PocketQube satellite. It's designed according to PocketQube standards. We choose 3P, that's one of them. Its size are 50 x 50 x 178 mm. The reason we choose that and sensors we use for putting to practice our mission. We use aluminum 7075 because we need the satellite to be resistant, have high endurance, and resistant to fatigue. The frame covered with fiberglass to make the satellite protector resistant to any strike, corrosion, and not get affected by hot and cold weather. There are some layers because of the sensor we put in the satellite. Some of these sensors are installed onto the wall and some are put on the layers by screw and secured by horizontal pieces. Also, we are using CNC machine while putting to practice satellite and frame. Frame covers the whole satellite and is composed two parts. On the upper part of the frame, there are some gaps for antenna to obtain data, etc. After the satellite leaves by using dark gunpowder, it uses the compact elliptical parachute to achieve a safe landing. As the shock cord caller will be used, the landing speed will be 5.34 according to the calculations.
Hello, I'm Tuana. I'm working on the electronics of the satellite. Now, I will talk about the components we use, the reasons for using them, and how they are connected. This diagram shows the connections in our satellite circuit. We use Raspberry Pi Zero as the computer of our satellite. BME 280 to measure humidity, barometric pressure, and temperature. It has a regulator with it, so we can use both 3.3 volts and 5 volt pins. And another sensor we use is GYML8511. With this sensor, we can measure UVA and UVB rays. Being able to obtain a lot of data with a small sensor enables us to use our already small satellite more effectively. We use 2 Li-ion batteries to feed our satellite and a voltage regulator to translate given voltage to 5 volt, which is the required value for the Raspberry Pi Zero. We use MTK3T39 to find the location of the satellite after it leaves the rocket, and since there are no analog pins on the Raspberry Pi, we use a converter, MCP3008. It allows us to use the necessary pins to obtain analog values from the sensors. We use a micro SD card to save the data and an antenna to communicate with the ground control system. The communication system will be explained in more detail in the data handling section.
Hi, I am Mertele. I am working on the software of the satellite in RedCarbon team. We are planning to use UYA and UYB with GVML 8511, temperature, barometric pressure and humidity data with BMI 2080 to collect atmospheric data. We are using a XP3 Pro with a Raspberry Pi Zero to send those data to our ground control system. Additionally, we are using a SD card module to save raw data. We are planning to test those sensors as a whole after testing them individually. We are planning to make some tests to check their connections, their readings and their heat characteristics.